So welcome everyone. Good morning, good afternoon, and good night to some of you, including speakers. This is the session on advancing color format in OpenType. We have three presenters for the session. Peter Constable, who has been very active in font and font technology for many years. He has worked in Microsoft in different roles and primarily dealing with font technology. Then he left the company and recently rejoined Microsoft as a senior program manager for typography and global standardization. So he is basically the lead person behind the OpenType spec, and he led, for many years, he's been the editor of OpenType spec and also led the cross-industry initiative adding variable font functionality starting in 2016, I believe. We also have Dominic as our speaker, who is a software engineer in Chrome team. And Dominic, I would say, became famous when he implemented variable font technology in Chrome. So that's one of his many achievements. And he's, like I said, he's an engineer in the Chrome team, working on variable fonts in Chrome layout engine. And Dominic also has a suggestion that for a quick, fresh start of the day, he suggested that ice swimming could be a very good activity, which is completely orthogonal to what Brad is suggesting, because Brad likes for the fresh morning start to have a hot shower and espresso immediately following that. So I'm not sure how we can reconcile both suggestions, but that's something I wanted to share with you guys. And Rod is the tech lead and engineering manager for Google Fonts team. He joined that team 7 years ago, started working on text and fonts, also as active participant for WAF2 development in Web Fonts working group. And by that time, Rod expected that it only will take a year or two maybe to fix all the text and font issues. Like that was 7 years ago, and he's still hopeful that will be the case one day soon. With that, without any further ado, I would like to ask our speakers to begin the presentation, and I am looking forward to your questions for this presentation. For the question itself, we have two windows. We have room chat and the Q&A session, which is the button next to room chat. I would like to ask audience to use Q&A session for questions directly related to the presentation, and then have everything else happening in the room chat. Thank you. Guys, go ahead.
I'm going to advance to slide 3. So just to start off, although I think this will be slightly old news to a lot of people here, I wanted to kind of describe what we mean when we say a color font and what isn't a color font. So slide 4, please. So one of the things that comes up when we talk to people is, don't we have color and fonts already? Like, am I not looking at color fonts on this screen right now? So I thought it might be useful to try and characterize a color font, perhaps starting with what a non-color font is. So if we ignore anti-aliasing, a non-color font uses just one color, and it doesn't specify its color. It just goes in whatever color text in its context happens to be. So the end user here, for example, is seeing a rendering in color or even in many colors, but the font didn't have a whole lot to do with it. It just said, put ink there, and something outside decided on what color would go there. Next slide. So by contrast, in a color font, many colors can be used within a single glyph. And when you drop a glyph in from the font, it isn't limited to just drawing in whatever the text color happens to be. In some cases, in some color font formats, you can use whatever the text color happens to be. And sometimes the user can change the colors and fiddle with the palette. But in general, the font has a lot more opinion about what the colors should be, and it offers the ability to have many of them within a glyph. Next slide. So for a lot of users today, the only color fonts they're really going to encounter are emoji. And emoji, it's fair to say, are a pretty major use case. But I think one of the things we want to try and emphasize is that they aren't the only use case. And it's actually really a shame that they're the only use case that's kind of taken off for mainstream users. So I just wanted to give one or two quick examples of other uses of color. Next slide. So this is one that I thought was cool. It's by David Jonathan Ross. It's called Bungee. It's a celebration of urban signage that has different color font formats. It's open source. You can play with it. It's awesome. Go forth and do so. Another example, next slide, and one that was actually kind of eye-opening for me is this one that Khalid tweeted recently from the Amiri family. And I really like this example because I think it shows in a very visceral way that you can just show to people and they immediately get it. The color's about more than emoji. It's not just display faces. There are practical use in text. And how cool would it be able to be to just use this font, assign it to some text in your browser or in your editor, maybe adjust the colors individually for each little fragment within the glyph. So if we can land a widely supported color font format, we might actually see a proliferation of color fonts across a whole range of use cases, which from a little bit of spelunking around, people have been kind of speculating about and proposing are coming any minute now for at least 5 years, and I imagine much longer. Next slide. So I want to talk a little bit about kind of where we're at with color formats today, just to set the stage for what we're proposing. Next slide. So the font format didn't do super well by color fonts. We ended up with a bit of a proliferation of formats. It seems like everyone invented their own format. And as best I can tell, with the possible exception of SVG, each format solved the author's problems pretty neatly and didn't necessarily do so in a way that works for other people. So if you take the bitmap formats, which I think Apple and Google each have one, you can get pretty nice renderings. You pay in terms of enormous files. If you want to be able to render at arbitrary sizes, you have to provide the bitmap at a bunch of different resolutions. And you kind of ignore the rest of the font format. You want to have variations, let the users set colors. All these things are quite difficult to achieve with bitmaps. So if we take SVG, which I believe is by Mozilla and Adobe primarily, you get vector graphics, you get a great deal of drawing power, but it comes at the cost of requiring an SVG engine and not integrating as smoothly as we might like with the rest of the font format. It's kind of embedding something separate rather than fitting graciously into the font format. And still, if you have an SVG engine already, this is a pretty good option. But it will mean that variable fonts, hinting, and a compact binary format are going to be a little bit difficult. Color v0, purely in my personal opinion, is the one that kind of came out best. It reuses a lot of the existing capabilities in the font format. It says, you already know how to define vector shapes. Great, we'll reuse that. We'll just have a table that tells you how to stack them up and how we color each layer. We get variations, we can have hinted things, we have a compact binary format. The one downside is that the painting capabilities are a bit limited, and we'll talk more about that in future sections. Next slide, please. So one of the great things about fonts today for text fonts is that if you're careful, because there are definitely some sharp edges in there, you can kind of have a font that more or less works anywhere. You drop your font in, you can probably draw text in it, it's going to work in most places. That's not really true of color fonts today. It's pretty hard to find a format that works well in all browsers, major applications, and although we didn't show it here, operating systems. And this is kind of, I think, why we're left with emoji being the only widely adopted use. If you're shipping an OS, you can drop a font that works with your OS onto it, and life is good. If you're trying to do something that works more horizontally, you've got a lot of problems. And with that, I'm going to pass over to Peter.
So let's talk, ask the question, what if? What if we could come up with an ideal color font format? What would it be like? Let's go to the next slide. There's several different factors we'd want to consider. One is the graphic capabilities. You want a rich set of graphic capabilities that will allow designers to realize their visual design ideas, whatever those might be. Bitmaps are good in the sense that the designer has control over every pixel, and so they can realize whatever it is they want. It just doesn't scale. And so, as Rod mentioned, you need to have a different bitmap for every different text size that you care about. And that can make the fonts really huge. So we want something with a vector format with rich capabilities. It should be a format that lends itself to extensibility so that we can add new capabilities that might be useful over time. And as Rod alluded to, we want something that integrates well with the rest of the format. For instance, if there's a feature that for which variations could make sense, then it should work in a variable font. Formats should be good for font developers, by which I mean that there should be a clear choice of the capabilities they can utilize and good tooling and workflows that allow them to go from initial design ideas through implementation of the design, testing and compilation of production fonts. The format should also be one that's easy for platform implementations in operating systems, in graphics libraries, and in applications. That's really going to mean that it's making use of graphics concepts that are well supported in graphics libraries, as opposed to inventing something that is really specific to a technology. Of course, we want compact fonts. The data that you come up with in the vector format should have a nice compact representation. And again, as Rod pointed out, we want fonts that work everywhere. You don't want to be having to explain to customers, I can gift the font to you in this format and it'll work in applications A, B, and E, but not in applications C, D, and F, unless I give you this other format. You just want one format that works everywhere in an ideal situation. Next slide. So we know we want a vector format, and we do already have two vector formats, the color format, the COLR table, and OT-SVG. And so there are these 2 points of view. We've got color, but we need more capabilities. Can the COLR table just be extended? There's a different point of view saying, we have OT-SVG, and SVG has lots of graphic capabilities, although the OpenType spec currently restricts which of those capabilities are recommended for use. Can we not just use more of the SVG capabilities? So I think it's important to ask the question, all right, how does SVG weigh up? Next slide. What are the pros and cons for SVG? It's got some definite advantages. SVG documents are well supported in design apps. In any modern design application, there's an option to export SVG documents. And SVG supports rich graphic capabilities. OpenType SVG font support is not costly to implement for application developers if they are in an environment that already supports SVG. But on the other hand, if you're in an app environment that doesn't already have support for SVG, then that becomes a very high implementation cost. Now you have to bring in all of the code that's needed for XML parsing, specifically SVG validation, and then CSS parsing as well. That is a high implementation cost. And it probably means that OT-SVG in the long run is not a color font format that will become really ubiquitous. There will always be environments such as embedded devices that have really stringent implementation constraints where adding all of that is not likely to happen. There's also this aspect of integration with the rest of the format, and in particular with variations. There is not really an easy way to integrate variations into SVG. It's doable. It would just not be very neat and compact. And then, while SVG is a vector format, it doesn't give the most compact data that is possible, which is definitely desirable. And we're going to see a little more about that data in a moment. Go ahead.
So with the considerations that Rod and Peter outlined, we've seen like the advantages that Color v0 has, such as scalability and integration with the format. And we've heard from Peter what the ideal situation for what would we want in a color format would look like. And like, what if we could have those capabilities in a color format? And these considerations are what motivated us to work on Color version 1. We wanted to build on top of the benefits of Color v0 For color v1, we want to integrate with the existing contour formats. We want to support TrueType and CFF outlines and not define a new path format. We want to preserve the capability to apply variations to the glyph shapes and still allow contours to be hintable if that's desired. For more expressivity, we want to provide richer graphics. One must-have is color gradients. It's desired by designers, and gradients alone already push expressivity a great deal forward. When thinking about gradients, quickly other features and concepts of computer graphics come to mind. Transforms, layering, and compositing. Those would be desirable to add as well. Also for the new concepts, gradient definitions, transformation parameters, our goal was to design those in a way that can be varied using font variations. And as Peter mentioned, with all that, our guideline during the design was, let's keep this compact and let's not waste any bytes in the representation. So the first example here is in terms of enriched expressivity color gradients. Here on the slide, you see an example from the Twitter emoji font on the right side, which has like these unicolor shapes. And on the left side, you have the golden leaves with gradients from the Noto color emoji set. So here you see an example of that expressivity. Also clearly comparing building on top of color v0, color v1 2 scales without loss in quality, and it scales seamlessly. In particular, if you compare to a bitmap font format such as CBDT, CBLC. Here you see an example of the Tokyo Tower emoji, and for reasons of video compression and so on, I've here magnified the bottom right half of the emoji, and you see that color v1 scales very at high quality. If you try and look at this example in a Chrome preview yourself, you'll see the difference in sharpness of these two renderings, which I had to amplify for this slide by a magnification. One of the design goals was full support for variations, and all added graphical elements and concepts are variable. For example, here in this slide, the color stops of color gradients can be moved using a variation axis. But this is only one example. You can generally control by variations all aspects of color v1. And last but not least, we have experimental data from our work on color v1, where we compare the sizes to evaluate whether we have reached our goal in terms of compactness. Here in this slide, comparing bitmap fonts to color v1. When migrating from bitmap format based on PNGs, we observe significant size reductions. In our opinion, with WOV2 compression on top of color v1, we can reach file sizes that make color fonts viable as web fonts. Looking at the WOV2 compressed size for Noto color emoji, we reduce 9.5 megabytes to 2 megabytes for a full emoji set, while at the same time seeing the resolution and sharpness improvements that we saw on the previous slide with Tokyo Tower. Also from our experimentation, we can compare whether we have achieved our goal in terms of compactness when looking at comparing color v1 to SVG. For SVG, you generally have a choice between a SVG representation that compresses well with WOV2 or a small file size to begin with before WOV2 compression, depending on whether you use SVG's own gzip compression. You see that in file extensions, for example, SVG or SVGZ. Our pipeline for building these fonts has a processing stage which we call Pico SVG, in which the SVG is simplified and flattened. That's why in this slide you find two sections for SVG. The gzip compressed Pico SVG processed output is the smallest before WOV2 compression, and the raw OpenType SVG format is the smallest after WOV2 compression. So let's just focus on the WOV2 compressed results if you think about a web scenario. The SVGZ compressed Pico SVG output is 9.1 megabyte after WOV2 compression, and the raw OpenType SVG ends up at about 5.9 megabytes. Color v1 with TrueType outlines, in contrast, is 2 megabytes after WOV2 compression. As you can see, our WOV2 compressed result for color V1 is about 35 to 45% the size of a comparable SVG file. So color V1 is compact, and we've reached that design goal. So I'll hand over to Peter to talk more about the graphical capabilities.
Sorry, I needed to unmute. So Dominic has given us an introduction to some of the capabilities, and I'm going to go into a little bit more detail on the graphic capabilities. Go ahead. So in particular, because we are creating an extension to the color V0 table, then I want to compare it to color V0. So this is here we've just got a few examples of color V0 glyphs, color V1. With color V0, you get a set of shapes, each of which has a flat color in it, layered on top of one another. We can think of color V1 as just being a small enhancement of that in a particular way. And so I'll explore that in the next set of slides. Go ahead. Next slide. Did we lose my connection, or?
I'm here again, but everybody dropped out briefly.
Okay. Go ahead to the next slide, thanks. Okay, so in a color V0 font, how do you create a color glyph? You start by defining a set of shapes, such as these that we'll use to create a smiley face. Next slide. And so then the next step is that you assign a color to each and then add them up in layers. And so we start with a bottom layer where we take the circle and fill it with yellow color. Next slide. Then we layer on top of that the glyph outline for a smile, but we fill that with a white color. Next. We finally put on top a layer with these eyes, but we fill those with the blue color. So basic concepts of taking glyph outlines and putting them together in layers with different colored fills. For color V1, you can do the same idea, but now you've got a little more capability in terms of the fills. So start by defining a set of shapes that you can use for your smiling. Next slide. But now you can also define some gradients that you will use in building up the overall color glyph. Next slide. So we begin filling in our layers. We start with the bottom layer with a circle, but now we're filling it with this gradient fill. Next slide. We then add a layer with the eyes, but now the eyes have got a gradient fill. Next slides, I'm putting in a highlight in the eyes. Next, add the smile. And finally, next, add one more glyph outline to give me a little more shadow along the bottom. So the concepts are very similar, but I've just extended with this idea of being able to use gradients to create a much richer effect. But that's just scratching the surface of what we can do. So I want to explore more of the capabilities. Next slide. Starting off with our different gradient types. We have 3 different types of gradients that are supported: linear gradients, radial gradients, and sweep gradients. Linear gradients will be familiar. One thing to note here is that for linear and radial gradients, the gradients extend along a color line. So you define a color line with some set of color values at different stop offsets from a beginning to end of the line. But the gradient actually extends indefinitely in either direction from that color line. And there's different ways in which colors extend along that. And so in the linear example, we're seeing a pad mode where the color value at the beginning and end of the line are what get used to extend the gradient out beyond the color line that was defined. In the example for a radial gradient, a different extend mode is used where there's It's the same, the color line is defined the same as in the linear example, but now the extend mode is extending kind of in a mirroring way, mirror back and forth the different color values along the color line as you extend out in either direction. Finally, the sweep gradient, it's also known as in some contexts as a conic gradient, where you're sweeping around from a central point with a given color radiating out from that center point, giving the effect of looking down from the top of a cone. Next slide. One thing that's important for compactness is ability to reuse components. So to be able to define something once and reuse it in many different places. So for these different cat face emoji, you can see they're all different, but they have many different elements in common. And so you want to be able to reuse all of those elements. We've got different ways in which reuse can be done. So you can define a particular shape and its fill and then reuse that multiple times. Or you could define a set of layers combining multiple shapes with their fills, and then have that layer group be something that gets reused in different color glyphs. And finally, you could create a color glyph as a complete color glyph definition, but then reuse that color glyph like a component in other color glyphs. Next. Transformations are important. Here with these 3 different clock face emoji, you can see there's a lot that's the same. We'll reuse things, but there is this one element, the hour hand, that gets rotated around. So we'd like to be able to reuse that, but apply transformations to adjust it as needed in each case. So that's what we'll do in the next slide. We've got the set of things to define the clock face, and we reuse those, but then we have this one outline and fill for the hour hand, and we reuse that, but with different transformations applied to get the different rotations for the hour hand. Next. We've got several different transformations that are supported. You can translate, you can scale, you can mirror, you can rotate, you can skew. And these can be applied to several different things in the color glyph definition. You can apply them to a shape. You can apply them to the geometry in a gradient definition. You could apply it to an entire layer group. You could apply it to some set of reused components. There's a lot of flexibility in how the transformations can be used in your color glyph definition. Next slide. Another important concept is that of compositing and blending, which has to do with how I take 2 different graphic elements or compositions and combine them together. Compositing, it talks about when I combine those 2 things, which pixels from each source are going to appear in the final result. If you're familiar with design tools, they may have, you've probably encountered what's referred to as layer masks, and this is very similar to that. There's also blending when you are combining 2 different things. How do the different color values from those 2 different source elements combine together? So compositing and blending for color V1, we're incorporating all of the capabilities that are defined in W3C's compositing and blending level 1 specification. I'll give a couple of examples of compositing that illustrate things that you can do that are difficult today. So first example, one thing that is difficult today is if I've got a shape and I want to use it to punch out another shape. So here I've got 2 layers defined. I'm putting the red rectangle as a background layer so that you can see what is hidden by the layer above or what gets exposed by punching out. So here I take the circle and I compose it together with the outline for the A, but I use a particular compositing mode that causes the A to act like a punch out of the circle. And so the layer underneath that red rectangle is showing through where the red is, where the red rectangle is. Next example, Here, again, compositing, but now what I'm doing is I am using a mode that allows me to create this gradation of one particular shape and its fill from full opacity out to full transparency. And so I define a gradient with alpha going from 1 to 0, from fully opaque to fully transparent. And then I apply that with a particular compositing mode to this circle. And that is going to cause that circle to fade out. And so the layer underneath is obscured in one part, but then over a gradation starts to show through. And finally, next slide. Dominic already introduced this idea of incorporating variation into the capabilities, the graphic capabilities. And in the particular example here, it is the color stops in the gradient definition that are being varied. Where exactly along the color line do the color stops get placed? But you can do variation with several other things. So in color V0, we already had the ability to do variation over the shapes. Now with color V1, we can do variation over the gradient placement in relation to the outline or the color stop offsets, as illustrated in this example. You can have variation of the alpha values that are applied to individual colors, so that you can have something that goes from varies as you move your variation axis from fully opaque to fully transparent or somewhere in between. And then all of the aspects that are used for defining a transform are variable. So for example, if I've got something that is rotating through a transform, I can vary the rotation angle. That's something that would be difficult to do today with variations. You can, we've seen Hoy effects that allow things to rotate, but it's an advanced thing with variations. Now this will make it very easy to do something like varying the rotation, a rotation angle.
So now we've talked about the design goals and the capabilities. So let's look at where are we at with Color V1. We've had this this open repository on GitHub to discuss the specification for a while, and we've now moved this into the OpenType alpha version, which is just published for broad review. For the ISO open font format, the amendment 2 is in progress. And we already published open source compilers and tools for producing Color V1 fonts. There is a new tool that we're releasing, which is called Nano Emoji, which takes input files from SVG and can output Color V1 fonts. And there's core support for the Color V1 format in font tools. On the implementation side, we have an implementation in Chromium via FreeType and Skia open source text and font stack. And there's now a brand new Black Foundry made this Python-based renderer called Black Renderer, which also implements Color V1 and impressively does that on the basis of several backends such as Cairo, Skia, Core Graphics. So to talk about a bit more about the Chrome implementation, there's some interesting news that in Chrome, the Color V1 implementation is ready for experimentation. You can download the preview version of Chrome, which we call Chrome Canary, which is a developer nightly build, which has all the latest features that developers of Chrome are working on. And in this version, you can experiment with Color V1. So you download it from google.com/chrome/canary. And then you have to go to the settings site called Chrome Flags. And there you search for Color V1 and you can enable Color V1 to experiment with it. And we're going to try to give a quick demo of that. Let's see. I have my Chrome Canary version here, and I'm going to switch to that. I hope that's arriving on everybody's screen. So here we have the Chrome canary, where I can go to Chrome flags. Then I search for color v1, and here in my Chrome canary version, this is already enabled. So let me go to this demo site. I'll resize this a little bit so you can see that better. So what I have here is bitmaps and color v1 emojis side by side. I'm using experimental releases from Google Fonts. On the top, I'm importing the color v1 version, and below I'm importing the CBDT CBLC version. Now again, in this video sharing over the presentation tool, you don't see the difference in sharpness that much, but if you try this out in Canary, then you will see the difference here. And to show you that this is actually live and a font, for example, I can remove these here and type an additional emoji, and that shows up here. So we have the full set of no-to-color emoji in this experimental glyph shape-based version available on Google Fonts, and the URL for this example will also be made available. We have it at the end of the slide in the references. Also, we're going to paste this to the chat. So yeah, feel free to download Chrome Canary. Don't forget to enable the flag here and try it out for yourself. You can download example fonts from our color fonts repository. You can make them with nano emoji, or you can use these experimental builds of no-to-color emoji from Google Fonts, which are part of this demo. So I'm going back to the slides. So how do we achieve that in the Chrome demo? At the moment, this is a preview, but when we are ready to make this part of Chrome's stable version, we can bring this all to all Chrome platforms where we ship our own rendering engine. And with this, we are independent of the operating system. Similar to what we do with variations in Chrome, for Chrome to support Color v1, it's not required for the OS to support Color v1. With the hybrid font stack in Chrome, we decide which rasterizer to use based on operating system support and font format. We look closely at the downloaded web font, inspect its format, what kind of color font is it a variable font, etc., and then look at and compare that against what the operating system rasterizer supports. If the operating system rasterizer does support the format, we pass it to the system rasterizer. Otherwise, we choose to rasterize glyphs using the open source stack rasterizer, here depicted by Skia and FreeType. So FreeType extracts the color v1 structural information from the font, and then we have an algorithm implemented in the Skia glyph rasterizer, which interprets those structures and uses the Skia 2D graphics operations to draw the correct pixels to the screen. So with the hybrid font stack, we can support Color v1 on operating systems where the OS itself does not yet have Color v1 support. We will be able to bring Color v1 support in Chrome to Chrome OS, Android, Windows, Mac OS, and Linux. Now let's talk about how to make Color v1 fonts, and I'll hand it over to Rod.
All right, so I just want to walk through quickly how one might make a simple Color v1 font using open tools. Next slide, please. So I'm going to assume that you have Python 3 and curl. If not, and you're on a Mac, Homebrew is your friend. And the way that this is formatted is that I've got some comments in. The gray text is showing the console prompt, and things in black are commands you type. And so most of this is just done at a terminal. Next slide. So first up, with the mkdir bit, we're just going to make ourselves a directory to play in, set up a virtual environment just so that we don't mess up with our system Python or anything. So now we've kind of got a safe playground where we can install things and mess with things. Next slide. So we can go and get Nano Emoji, which is our experimental color compiler, which supports SVG and color, and maybe one day it'll support bitmaps too, we'll see. And it should eventually tell you that it's successfully installed. After that, we need some art. I'm not an artist, so I'll cheat and go and fetch a file from Nano Emoji. So curl's just going to go and download emoji 2604 from Nano Emoji. Next slide. So now the simplest way to run Nano Emoji is you can just point it at one or more SVG files where the names are indicating the code points to activate. So we'll point it at this 2604 FEOF SVG. It'll dump a bunch of noise to the console and then say that it wrote a font. You could then go and find your font and discover that it's in build font TTF. Next slide. So in order to try it, we can just make ourselves the little demo page, which basically just says, use our font, and we'd like to draw 2604 FEOF twice, once in whatever the system font happens to be, and once in our shiny new color font. Next slide. So we can spin up a little web server to enable us to try this out. Load up Chrome Canary, make sure you're using Chrome Canary, make sure you go to flags and turn on color v1, and then open up localhost demo. I see I forgot to put the port, but I have to fix that. Next slide. And then what you should see that is on the left, you have whatever your system emoji happens to be, and on the right, you have the one from your color v1 font. And I'll pass it off to Peter to talk about prospects.
So we want to close up our presentation just talking about what we see as possible prospects for color v1. Next slide. So we've got a reality now where we've had, as Rod introduced earlier, we've got multiple formats, and we haven't reduced the number of different formats there are. And so anybody creating color fonts today will want to figure out which of these formats do I want to use. And they've all got different pros and cons. As mentioned, the bitmap formats are the best in terms of design capabilities because every pixel can be controlled, but there's not scalable. And you end up with huge fonts. Color v0 provides a compact file size. It's actually well supported in operating systems and browsers, but it has little support in graphics apps. Maybe that's because of the limited capabilities. I think it's a little ironic because if you look at display faces color display faces that are out there, I see an awful lot that are implemented with OT-SVG, but they could have been implemented with color v0, and they would end up being supported in color v0 is supported in all the browsers and in each of the main operating system platforms, but it's not supported well in graphics apps. So that's a trade-off there that against color v0. OT-SVG, we've seen some great things about it, but we've seen some downsides, one of them being there's no variation integration. Color v1, I think we've called out some things that are good. OT-SVG is great for authoring in design apps. Color v1 gives you the same set of authoring options because we've got workflows that can use SVG documents as part of the workflow for creating color v1 fonts. The graphics capabilities are going to be comparable to OT-SVG. But we've also got variation integration. And as Dominic showed us earlier, we've got more compact file sizes. The big question is, this is new, will it take off? And that's still an unknown. So certainly today and for the near future, if you're considering creating color fonts, you're still faced with this conundrum of knowing what your target environments are and then figuring out which formats are well supported in those environments. Next slide. In terms of the prospects for color v1, I'll go back to the slide that we had earlier where we asked what are the factors that we would want to see ideally. In terms of graphics capabilities, color v1 is providing that. It's an extensible format. It integrates with the rest of the font format. And we've seen that it produces compact font data. Is it going to be good for font developers? We've shown a workflow that makes use of open source tools and SVG artwork created with as SVGs. But different people have different workflows that they use for producing their fonts. Will this get supported? That's an open question that we can't answer yet. Easy platform implementation. We've made a point, at least for version 1, to make sure that the graphics capabilities are things that are well supported in graphics libraries. And we think that it's should be fairly easy to implement. Dominic mentioned a second independent implementation that's already appeared. But will different vendors start to support it? Of course, each vendor has their own priorities that they have to follow. So we can't say yet. We ultimately want fonts that work everywhere. Will Color V1 get us there? It's too early to say. But we think that there are lots of things in its favor that might get us to eventually to one font format that can work everywhere. Next slide. So future possibilities, there are already several ideas about potential enhancements to build on in the color table, adding more graphics capabilities, particular interest in having more filter effects with blurs, different lighting, introducing the idea to make use of bitmaps, for instance, if you want bitmaps as a pattern, adding mesh gradients. Now, of course, anything that we add into the color table, one could say, well, those are things that could also be added into OT-SVG, and that is true. There's also some ideas around enhancements to the CPAL table that could be useful in color fonts. So we've talked about variation of alpha values, but not of the color values themselves. So we could have variation of the color values. We could support different representations for color values, such as HSL or Lab, LCH. And in fact, if you want to do variation of the color values, something other than RGB is probably desirable because other representations may be more useful for continuous variation. And then things like wide color gamut or HDR are other possibilities. So the extensibility is definitely something that's been in our mind. These are not things that that work has started on yet, but they're definitely ideas that people have expressed interest in. So finally, with the last slide, here's a set of references that you may find of interest. The first link will take you to the draft for OpenType 1.9, an alpha that's out for broad public review. There's also a link to the original source of the proposal. Links to some sample color fonts and the open source color font compiler, and then the demo in CodePen that Dominic showed earlier. And so now we'll open it up for questions and answers.
Thank you, everyone. That was really enlightened presentation. And there are a few questions asked on the Q&A page. Some of them are related to each other. So there was a question about hybrid fonts, how to use them, if there are fonts that incorporate multiple color technologies in them, and also what your experience, if you had seen any of those fonts, what's your experience with them?
So I'll comment on that. So certainly in Microsoft's platforms, this may be a platform by platform difference. Certainly in Microsoft's platform, there is allowance for hybrid fonts with either with a default set of fallback behaviors or ability for applications to choose if they have a different format supported, which priority they give them. So in Direct Write, when we added color font support, when we added support for SBIC, CBDT, and SVG tables, we built in logic to say, if there are bitmaps, that's probably going to have the preferred designer preferred appearance. And so give the highest priority to the bitmaps. If there's SVG, pick that next, because SVG has a richer graphic capabilities than does Color V0. Finally pick Color V0. That's a default set of fallback logic built into DWrite. But of course, applications can choose to pick their own fallback behaviors for different hybrids. I can't speak to other platforms, obviously. I don't know if Rod or Dominic know what the behavior is in Chromium or Android.
Yeah, we're definitely looking at least making different glyph definitions available and working in parallel. So imagining like a Color V1 font that also has just outline contour glyphs, for example.
It's also worth pointing out that the way the color table is defined is you could mix color glyphs described using the V1 formats as well as the version 0 formats. So either some glyphs that are defined only with version 1 and other glyphs that don't need additional graphic capabilities being defined only in color with the V0 formats. Or perhaps having color glyphs for the same thing, but defined with both formats so that your font has a more graceful fallback in applications that only support color V0.
One thing I'd also like to mention before we later close the presentation, I'd like to thank everyone who was involved. I mean, it was Peter, Rod, and me presenting here, but we would also certainly like to thank Berat Esfabot working with us on the specification, Cosimo Lupo working on the test fonts a great deal, and others who've contributed to the specification, such as Benjamin Wagner, Dave Crossland, Lawrence Penny, and others have given us their feedback and done reviews. Chris Lilly as well, and a couple of names that I did not mention so far.
Vlad, were there other questions?
Well, I bundled them in one. So again, the hybrid font-related questions were concerned, for example, about also user recommendations. If you have a font that has multiple different technologies implemented in one font, what the user recommendation would be. So that was kind of on multiple different flavors for similar capabilities implemented in the font.
Yeah, maybe I can contribute with one that, as you mentioned, Peter, on the presentation, that we can use components to save space while you go. So I wonder if there is a possibility to see how much space you're saving as you go, to see which components you should be adding, or is something that you just see at the end.
Rod, do you want to take that? Because I think, Rod, you did some evaluations in some test cases.
Yeah, what I'd really like to have happen is that basically you just draw and don't worry about this, and then the compiler figures out all the reuse. So the compiler can look at two shapes and figure out that, you know, A is the same as B, or you can get from A to B via an affine transform. We have a fairly basic implementation of that right now, and I think it could be built on. But actually, one of the things I really like about the way Color V1 is currently structured is it kind of opens the gates for the compiler to become smarter over time. Like a lot of work is moved out of the part that's doing the rasterization, and you kind of figure things out at compile time and prepare this graph, which is at least intended to be fairly straightforward to process to actually draw something.
All right. Yeah, thanks for that. So just a reminder, we are 2 minutes left in this room. And then I think after that, the room shut down automatically. But then, of course, we join everybody to continue this conversation in the Hangout space, because then also the others may join with video as well. That's what has been happening before. I'd like to thanks everybody for, especially on the chat as well. It's been good to see that everybody that can contribute with something with this topic. So yeah, Vlad, do you want to close it up and then invite people to go to Hangout?
Yeah, I think I wouldn't want to close the discussion. I'd like to encourage everybody to just transition to a different place where we can keep going and will not be restricted by any time constraints. So thank you everybody for joining the virtual presentation room. And now it's a good time to just switch to Hangout rooms and stuff.
See you all on the flip side.